Okay, hey guys, so I'm going to go over problem number 2 for the video problems, and these problems go over how to solve for derivatives in different cases. And for problem number 2, it has a part A, B, and C. So we're going to go ahead and get started. So for problem 2, part A, the problem reads f of x equals 2/3 minus x to the 4/9. And when you have a problem like this, you use the power rule, which means that you multiply the number in front of the variable by the exponent. So that's what you do here in order to get the n in front. And then the exponent, which again is n, you subtract that by 1. So in this case, for this problem, you assume that the number that's in front of the variable is 1 because you don't have any other number in front of it, so we just assume that it's 1. You would multiply 1 by 2/3, and then you'd multiply 1 by 4/9, and then you would subtract the 2/3 and the 4/9 by 1, which gives you the answer of f prime equals 2/3 x to the negative 1/3 minus 4/9 x to the negative 5/9. So then for part B, the problem reads f of x equals 4 over x to the third plus 7x minus 4x to the fifth. When you have a variable that has no number where the exponent should be, you always assume that the exponent is 1. You're always supposed to assume that. So for part B, you use power rule up here again for part B as well. You just put that, apply that down here. And then when you have a fraction that has a variable in the bottom of it, you want to rewrite that as like, for this case, 4x and negative 30, you want to put the variable right next to here, and you always want the exponent like that. So when we rewrite this problem, it's rewritten as 4x to the negative third plus 7x to the first minus 4x to the fifth. And like I said before, you do power rule for this. So you would multiply the 4 by negative 3, multiply the 7 by 1, and multiply the negative 4 by 5. And then you subtract them all by 1. So when you do that, that ends up getting you negative 12x to the negative fourth plus 7 minus 20x to the fourth. The reason why 7 here doesn't have a variable anymore is because when you subtract 1 from 1, that gets you 0. And anything to a 0 power always equals 1. So then that means that you would just get rid of this. That would become 1, then 7 times 1 is 7. When you rewrite this, though, you want to rewrite it as negative 20 x to the fourth minus 12 over x to the fourth plus 7 in order to get your f prime value. So for the last part of this problem, the problem reads f of x equals 3 to the square root of x minus 7 to the x power plus 22x minus 4. When you have a square root in your problem like this, you want to, and like when you're finding the derivative, you want to rewrite this as x to the half when you're finding derivatives. And then in order for this particular problem to be solved to find the derivative, you have to use exponential rule, which basically means that you want to find the natural log of the number that has an x in the exponent. So for this case, we would be finding the natural log of 7 right here, and putting it in this form, you would multiply 7x times ln to the 7. And then you also use power rule like you normally would for these problems. You would subtract again, which I have written out all right here. Again, x to no power usually is just 1. 3x to the 1/2 minus 1, 22x to the 1 minus 1, and then 4 actually doesn't have a variable. So when we find the derivative of this problem, 4 does not exist after, which ends up getting you to the problem that looks like this. After multiplying 3 by the half, you get 3 over 2x to the negative half minus 7 to the x times natural log of 7 plus 22. Because like I said before, 4 cancels out. We don't care about 4 anymore. Which ends up getting you f prime over here. You want to rewrite this problem like this. So it'd be 3 over 2x to the half minus 7x times natural log of 7 plus 22.